turned up the volume.
Now, let me
And
get
stuff.
this pulled up.
Oops.
Why?
I was supposed to work on my concept 3 today, but looks like I'm not doing anything.
I'm just gonna pull it up on the screen here. It'll be easier for us to all see exactly what it was we were looking for. Oh dude, what happened? Why are you so small? Okay. So, this first part, okay, our essential question here was, what patterns can be found in the periodic table to make it possible to make predictions about how an element will behave? Okay, atomic radius is a big one. Okay, so first we had to define atomic radius. You should have had some sort of a picture in here that looks like this. Okay, the definition of atomic radius is half the distance between the nuclei of two identical atoms. So you would have drawn two atoms that are exactly the same size, a line in between their electron clouds, but the radius is the distance halfway between those nucleus. Okay, so you have to be able to show that at some point. And the only way to do that is some sort of a bracket, or lines, or arrows, or so forth. Okay, so number 2 says, why is it better to use a measurement of atomic radius versus just measuring the diameter of the entire atom? We've talked about this before. So I'm going to call on somebody to give me the answer. How about you, Hunter? This is number 2.
It gives a better, more accurate measure.
Why? Why would you think it gives a more accurate measure? Could it have something to do with one of the subatomic particles? We know of 3. Protons, neutrons, and electrons. So when we're talking about atomic radius, what is this stuff out here?
Electron?
Yeah, that's the electron cloud, right? So those vary depending on what atom it is, right? So that distance will vary, okay? So this next part, people were having, I think, some problems at least getting started with this graph. You were supposed to use, I think my filmmaking was a little slow. We were supposed to use the data from this chart, okay, to construct a line graph here. Different colors for different group elements, okay, or different families, different groups. This was your x-axis, this was your y-axis. You would have had to develop your scale accordingly, right? So the bottom, it tells you specifically in here to put the atomic number on the x-axis and the atomic radius on the y-axis. So your graph should have ended up looking like this with a scale of 1 to 20 on the bottom, 0 to 250 on the top, on the x-axis, I'm sorry, the y-axis, okay? So we have, if you would have labeled it to a proper graph, has the proper labels. Okay, we already have the title up here. This is something that I see over and over again. People will construct a really nice graph, but then they'll forget to put the labels on. Okay, you don't want to forget to do that because a graph shows a reader exactly what, it tells a story, right? It tells you exactly what happened. Okay, so you should be able to interpret from this. Okay, now you had different colors to indicate different groups, and you should have been able to see a periodic trend there. Okay? So I'm just going to go through a few of these, and I'm going to call on a few people. So who had a good answer for number 4? So refer to the graph and the pattern you see. Which colored dots represent the peaks on the graph within the pattern? Or what group does these belong to? Ashley?
Oh, I said red dots in group
Yes. And what group are those?
1.
Yes. And does anybody remember what group 1 elements are called?
Alkaline metals?
Alkaline metals. Very good. Very good. Okay. So let's just talk about the trend that we saw here. So it says refer to our graph. Like what kind of pattern do we see for the radius of the atoms as you move across a period? You can't, unless you constructed this graph yourself, you wouldn't be able to tell, right? You need to know what the red dots mean, what the pink dots mean, the yellow, and so forth, right? But we know from all of our notes and our lecture material that we had moving across a group, periodic trends happen, right? What kind of periodic trends happen? And that's all dependent on the number of electrons they have, okay?
Are you going to do the group?
So what would you think going from left to right on the periodic table? You can look at this one up here, you can look at the one in your notebooks, anywhere. What do you think that trend is for atomic radius, going left to right? Jamie, how about you? The atomic radius decreases as you go left to right. That is true, but it starts over again as you go for a new group, so that is good. All right. So now let's talk about how we move down a group. Does it go up? Does atomic radius go up or down when you move down a group? Atomic radius. Oh, I forgot this. It hasn't been fixed yet. Anyway,
It increases.
it increases? Yes, it does. Why does it increase? Why would atomic radius increase as you go move down a group? Kayla? You know. If it has more electrons, right, and we just talked about it has more electrons, it gets, that atom will get bigger. So what happens if the atom gets bigger? Yes, Colton, very good. All right. We are going to go, sorry, this might go a little bit fast, it's lagging. Let's talk about electronegativity. We're going to be playing a game after this, so I want to make sure you guys are clear on the periodic trends for atomic radius, electronegativity, ionization, and we're going to be talking about reactivity as well. And ionization, electronegativity, atomic radius, and there's one more that I don't remember. But we'll get to it. Okay, electronegativity. We have another data table that you guys had to graph. This time you had to do a bar graph, right? X, Y. We have electronegativities here. Electronegativities are usually very small numbers, okay? So on your y-axis, you should have indicated that each block was 0.2 on the y-axis so that you are able to get high enough bars on your graph that look like this. This is what your graph should have ended up like. Okay. We learned in the last concept that we have electronegativity differences, right? What is the difference? Mark. How do you calculate a difference?
I don't know.
Well, think about it. Would you add something together? Yes. So you would subtract. Very good. And it doesn't matter if it's negative or positive. You just take the absolute value. I usually stick to the practice of making sure that I subtract the smaller one from the bigger one. Anyway, so that we don't have to worry about it. Okay. We all did an activity already for determining the difference in electronegativities, and then we also decided what kind of bonds those are going to be, right? So if something has a bond greater than 2, is that an ionic or covalent bond? Ionic, very good. So the electronegativity difference is big, right? There's one more way we can tell that something is an ionic bond. How do we do that? Does anybody remember? Because I think that was just kind of touched on a little bit. But if you know that there's a metal, right? All of these to the left of the staircase are metals, and that is bonded to a non-metal. That is an ionic bond, okay? Also, if electronegativity difference is greater than 2. And you can tell the further apart they are from one another on the periodic table, the electronegativity difference is going to be greater, okay? Electronegativity difference 0.5 to 2 is, what kind of bond is that, Helen? So we've already decided that the ionic bond was the strongest one, not strongest one, but it's like the highest one with electronegativity difference.
Is it polar?
Yes, it's a polar covalent bond, yes. And then we have one more that we have an electronegativity difference less than 0.5. We all did a really good worksheet on this, so hopefully,
Covalent?
yes, covalent bond. Yes. That's all this electronegativity trends we're talking about, similar to our atomic radius. Do you guys remember which one, what element I said was the most electronegative? And then also that you guys determined was the most electronegative on your periodic table?
Is it neon?
Oh, you are very close. Now, Jamie said neon. Who can tell me why it would not be neon? Colton? Oh, sorry, I thought you were putting
Oh,
your
it's
hand up.
fluorine. It's fluorine.
Yes, so it's fluorine. Okay, but I do want somebody to answer that question of why it wouldn't be something in this.
Is it because it has a full outer shell?
Yes. All of those in the last one have a full valent shell. They don't play well with others. They don't want to bond. Okay? You guys are doing really good here. We're going to move to ionization energy on here. You were to create another graph. Your other graph should look something like this one. We needed to define ionization energy, which is the amount of energy needed to remove an electron from an atom, from a neutral atom, okay? That's what ionization energy means. Hopefully, these vocab terms and going through this will help you with that on your study guides. Now, ionization energy trend follows electronegativity. So, if you were to write these down on your periodic table, which I suggested that you do that, then you would have those arrows going in the same direction. So they would be going from the left to the right of the periodic table, okay? And then from the bottom to the top on the right-hand side. That's all we have there. Now I'm hoping on this next game that we're gonna play, this or that game, this is why we have these out on our table. You're gonna have to determine whether an atom is gonna say this or that underneath, has maybe a higher atomic radius, or has greater electronegativity, or whatever. I'm gonna put you guys in groups, and then we're all going to decide together on what they are. So what you can do is keep your notes out. I would suggest having, there's one in here. Really good. Page 20, is it 26. So if you open up your packets to page 26, you'll have a graphic there that has all of the trends on there if you need to peek at that. Okay. Trying to think something because we didn't really talk about. Do you remember going through reactivity? Okay.
This one?
Yeah, this doesn't have reactivity on it. However, in your study guide, it talked about needing to know reactivity. Somebody in my last class, they had a really good.
Because you were like, asked us like, what is reactivity? Or you went around and asked us what it was.
So do you know?
When something like reacts to another item.
Yeah, I think it was very basic what we had talked about. So it's just kind of hard to tell sometimes. I think on the periodic table. So I just wanted to make sure that everybody was clear on that. Okay, I'm gonna get out of this and I'm gonna stop.
There's a calculator in here. There is.
That's our collection.
There's a lot of stuff in there. Like if you look to the sides. Wow. There's a lot. Goldfish. There's goldfish.
My internet seems to be rather slow.
Page.
Okay. It's showing you guys all the answers. Okay.
It has the answers on it. Oh wait, no, it doesn't.
Okay, here we go. At risk of showing everybody already all of the answers. Yes. Okay, so do you guys have, let's see, you guys can work together. How about you three?
Us three.
You guys can work together with this set. And then you three, you guys got a set.
I gotta press something on.
And
Oh my God.
you guys can work together.
I'm getting all the two.
And you three, do you guys have a set?
The new one.
You guys have a set there? Perfect. We
Is
can
it
do it
anybody-
in. Oh, you're good. Okay, good.
The head volleyball coach position and JV head volleyball coach position.
How about wait till after we're done with
Ooh, let me get all the teachers. So guys, I'm that.
I think you might want to hold it a little bit closer.
This one, I go quick.
You may print concept 3 out when we're finished with the game. Okay, I'll finish a couple minutes early so you can go do that. Does that sound good?
Oh, are we not supposed to raise it yet?
No. So we'll wait till, I just wanted to get everybody started and get the information. So everybody's clear on what to do? You just say, you're gonna decide together if it's this or that and just hold it up and then I'll know. And then I'll know whether to go on to the next one or not.
It's like the.
Or reveal the answers.
It's like bigger. It's just like.
Okay, so which has a greater atomic radius? This or that?
I just.
We're all saying
Can't reach.
that. That is correct. Also, which one has the bigger atomic radius? Greater or bigger squirts? We'll see. We have one for this.
Paige, what's your answer?
That.
That, okay.
That.
There we go,
Oh.
you guys are so smart.
What?
Okay.
I thought it was that.
Calcium or chlorine? This or that?
I thought it was that.
I wasn't. None or first.
This?
Yep.
That?
How do we
This?
tell again?
This? So atomic radius will increase as you go down. the group, right?
Yeah.
Or left to right. So
So-
down here.
That. No. This.
Okay, I think you are correct if you said this.
If you go down.
There you go,
higher
good.
atomic radius.
So you can tell by on your periodic table the trend was for atomic radius moving down, it increases, and then it increases this way. Okay. So these are going to be the higher atomic radius here.
Like when you go down.
Greater,
it
higher,
increases.
bigger. All of those words work.
So if the.
Okay, now we still sticking with atomic
She has to
radius.
for teaching.
K is
Just
this,
which one has a
BR
bigger
is that.
19. It's that.
Okay, we have a mixture here.
35.
Okay, I'm going to reveal the answer. It is this.
Okay, now I don't.
So, okay, Derek, why were we thinking that? Just to try to correct
like
the
how-
understanding.
Thought it was bad.
Just thought it was that. Okay, so it would be helpful to, and maybe if you have that one page open on your notes, the page 26, that should help you because those arrows will indicate, and then you can look on your actual periodic table here and see where that is. This is helping you in more ways than one. Like first, you're having to figure out where it is on your periodic table, so it's helping you navigate that. Plus, it's helping you figure out what those trends are. Okay, I'm gonna go to the next one. Now we're talking about reactivity. Which is more reactive, lithium or beryllium?
Oh.
And with this one, you'll want to think about this in terms of electrons.
I mean, yes.
Saying that. Okay, Paige says this.
No, it's that.
Ashlyn says that. Okay, this group, and I've got a big mixture here. Okay. Okay,
So we were listening.
okay, we gotta figure out why we're
Wait,
thinking it was that over this.
Oh no, he's dying.
So think about it. If you have something that has one valence electron, which lithium is one, beryllium has two valence electrons. Okay? So which one is easier to bond with?
Li, because it only has one.
Yes, Li only has the one in its valence shell. It's so much easier to pluck one off and bond than it is two.
I'll get this.
Okay. Si and S. Silicon and sulfur. Got that? Most everybody says that here.
Put that up.
That it is.
It's that, was that? I thought that.
That it is.
And then.
Oops. Sorry, I just
Yeah, you gave it away.
I just gave it away. I'm sorry. I thought I was on this one. It's okay. Okay. So we're already having that here. So we have which one's more reactive? Sodium or chlorine? Is that?
It's
We've
chlorine.
already revealed the answer. It is that. Okay, now we have another one. F or I? Is it? No, they would not be the same.
I don't know. Wait, because they're both in the same column, so they're both -1.
Okay.
So
It's the amount of electrons you're supposed to.
Yeah, but they would both have the same amount of electrons if they were in there. But which one?
Just go with that.
so this one has a smaller number, so
Yeah, I would probably go with fluorine. Like, if you ever see fluorine on there, it's always the answer. It's always the answer, because fluorine is the most electronegative atom, right? We started this out by talking about that, right? It reacts with a lot of atoms. Okay. Carbon or neon? Carbon or neon? Wait, we still have what, 5 minutes left? Yeah, 105.
10.
This, we're all saying carbon, this.
Yeah.
All right,
this or that.
there we go, it is this.
Oh, I don't know.
That time. It's this that time. Which has a greater electronegativity?
Electronegativity.
Sodium or chlorine?
Where'd you put your notes away?
Is that another big 11?
No, what's this big?
It's the same one? All right, I have a couple of that's up. That. What do you guys say? You guys say that?
Oh, can you get your notes out?
It is that. That it is. Which has a greater electronegativity, magnesium or chlorine?
Okay, magnesium.
What's up, Caleb? You locked in?
That's a great.
Okay.
Oh, Miss Mia.
Just checking on you guys over here. We're gonna stay focused on the game.
I think that this one's more up.
Okay, you can put it in the folder when you finish, okay?
Should I go grab
If
mine?
I grab it, I'm gonna take it over here and I'm gonna stick it on my thing. Right for the game, and I'm probably not gonna do that. But I trust you to get it over.
Alright, so we don't like moving.
It's the one from concept 2 or?
I don't know.
I'll let you go a couple minutes early so you can go do that, okay? Alright. Here we go, it is this.
It's just so, yeah, it takes
Oh.
Whichever one's more this way and up.
Okay, so remember guys, so for those of you who picked that, remember electronegativity runs from left to right, okay, from bottom to top. If you use fluorine as your guide for electronegativity and ionization and reactivity, you'll be fine, okay? Use fluorine as your guide. Know that is the most electronegative, the most ionizing atom there is, okay? Here we go. Carbon or oxygen? This or that? Which has a greater electronegativity? Talk it over if you need to.
Yeah.
That?
Yes.
That? Yeah. That? Okay, look, sounds like everybody's all in agreement.
You have to like close your eyes and then you're like,
There we go. Wait, was it this one or did I mess up?
10 minutes. So that
She treats all of her classes different. Like,
we've done it.
It is that. Oxygen.
I have
Okay,
it.
it's to the right of carbon on the periodic
I
table.
don't have it, but I have one.
Okay, F and I. This should be a no-brainer. Everybody, boo. What is it?
I didn't do
Boo. Yeah, we all got it. Yes, there you go. Very good. Hydrogen and helium. Which has a greater electronegativity? Got some that's going on. Alrighty. It is this. Why is it this? hydrogen and helium, they're kind of different animals. They don't follow our trends, right? Why else would hydrogen and helium be up above, right? Hydrogen kind of is its own little animal. It only has one electron. Helium has two, but it's a more valence shell, right? It's full. Its electronegativity is going to be what? What's helium's electronegativity going to be? It's a full valence shell. So over here, it's above our group 18, but it also has, because it only has two valence electrons. But those are that's the only electrons it has. It's a full shell, so its electronegativity is going to be 0. Okay. So are all of these. So it makes more sense for it to be hydrogen. Okay. Which has a greater ionization energy, aluminum or chlorine? Okay, Caleb, you need to go ahead and go print that out now and come back. Anybody else need to go print out their concept 3 study guide before the end of class? Because that is due today. All right. Excuse me?
Concept 1 and 2 are both blue red.
Yeah, I had concept 2 due on Monday of this week, but I told people they could have till Tuesday. So if it was turned in after Tuesday, it's late.
I need to print all my stuff again.
You need to print all of them out? Okay.
Yeah, I need to print them.
All right, we're all saying that, and when Caleb gets back, I'll let you go and print yours.
I have to do mine too.
Okay, it is that. Very good.
I have to print mine too.
Okay, when Caleb gets back, you can go. Okay. Which has a greater ionization energy? Remember, ionization energy trend follows that of electronegativity. I have a that up in the air. I have, many that's. That it is. Here, we have potassium and lithium. That.
When you got your tattoos, did they ever itch? Oh my god, it's really bad.
That.
Yeah, and then
I
like
just want to scratch the head.
That.
I just have to bang it.
they're just like flawless skin, but it's like black, so you can like scratch it off really good.
That it
Turns
is.
black, like the
We're
dry
still
skin.
talking about ionization energy.
Mine hasn't yet.
Hydrogen and
Mine's not black.
helium.
No, no.
Here we go. We visited this back. What is it? You guys should just boom, light up first thing.
It's just itchy. And I just have to go like smack it.
There you
and
go.
Mosquito away.
Ah, why is it saying helium? I think this is wrong. That's wrong.
Oh my gosh.
Okay, which
That is
has
what
a
I
greater
read about.
ionization energy? Sulfur or fluorine?
Is our bridge assignment the same for everyone, like in our class? Because I'm just gonna see if I can keep up with this. Because I just don't get what it's asking us
Okay.
to do. It says to like everyone pick like
There we
the
go. It is
website.
that, the fluorine. Okay, we're
No.
almost done. We have just a couple minutes left. Since we only have a couple minutes left, why don't you two go and print those, okay? So you can get back. And then we'll finish up this game. We only have a couple more to go. Okay, so stay with me here, guys. I know this game feels like it's getting a little bit long, but this is different now. We're not dealing with ionization energy or electronegativity or atomic radius. This one's asking, which one is more likely to form a cation? Helen, let's get, maybe help commiserate with your friends here. Zoe, maybe you can help.
This is more like you have to do the
Calcium or sulfur? We have one this, another this.
I don't even know. I don't even have a paper or anything.
It is. Hey, remember, the ones on the left-hand side are the ones that are gonna be positive. The ones on the right-hand side are going to be negative. And positive ones are cations. Negative ones are called anions. Okay, which one is more likely to form a cation again? Boron or carbon? You can't held them both up.
We're going against
No, we're
each
having
other.
a competition. Like whichever, like we just grab one real quick and then see which one's right.
Silly billies.
Miss Mejia, can I go to the bathroom?
Oh, you didn't want it.
Yeah, like I just.
Sorry,
Can I
what?
go to the bathroom?
Do like crock pots.
It's.
Yeah, sorry, I just do
think
crock
that's anybody
pot.
last 5 minutes of class.
I do crock pot.
Wait, put her down.
Okay, it is this.
Yes!
Oh,
I'm
dang
beating
it!
you.
Two. And
Okay.
now we have our
Get
anion.
down.
Which one is more likely to form an anion? This is our last one.
Well, I guess.
I don't know.
Oh,
wait,
it's a
no.
mixed
I'm
group.
wrong. I'm wrong.
Ooh,
thought it was
a mixed
Awesome.
move.
Florida wins.
I thought it was Cat.
There we go.
Mom.
All right. Good job, you guys. And wrapping that up.
Yes.
Hopefully you guys are better prepared, and I'm going to have your booklet ready for Monday. Okay?